All right, here's solutions for quiz 5 for Math 211. Bunch of problems here. Starts out with some, I guess we're talking about the different properties of addition in this first problem. It says to try to calculate 7 plus 18 in my head. I first recognize that the answer will be a whole number equals a whole number. That might seem like a dumb thing. I don't know that I really do that. But I wanted to write that in here because this idea that when you add together two whole numbers, you automatically get a whole number is what's called the closure property. I guess the closure property of addition on whole numbers. Meaning take any two whole numbers, add them together, you're guaranteed to get a whole number. So the fact that 7 plus 18 equals a whole number, that's a closure property of addition. Okay, I then changed the 7 into 2 plus 5. So I got 2 plus 5 plus 18. And then I grouped the 2 and the 18. Wait, but the 2 is way over here and the 18 is way over here. So I guess what I have to do is I have to change this so that the 2 and the 18 are next to each other. So maybe I could write it like 5 plus 2 plus 18. And then from here to here would be the commutative property. Of addition. Commutative property just allows me to switch the 2 and the 5, switch the order that I add things in. But then I group the 2 and the 18, which I add together to get 20. That's what's called the associative property. Your normal order of operations, well, they're all addition, so it ties, so you work left to right. You'd add the 5 and the 2 and get 7. But I don't want to do that. That would take me back this way. I want to add the 2 and the 18. Well, if I'm going to add the 2 and the 18, I have to put parentheses around them to force myself to do these out of order. And that's the associative property that allows me to group those right there. And then finally, I add those together to get 25. So the properties that I use are the commutative property, the associative property, and the closure property of addition on whole numbers. Okay, same basic idea down here, except now I'm going to calculate 5 times 18 in my head. So first of all, 5 times 18 is a whole number. That is, much like up here, the closure property. However, this time it's not the closure property of addition, it's the closure property of multiplication on whole numbers. Really, if you just write the closure property, I'm probably fine with that. Closure property says if you have two whole numbers, multiply them together, guess what? You're going to get another whole number. The fact that that's true, that's my closure property. Okay, from there I changed the 18 into a 10 plus an 8. So I got 5 times 10 plus 8. And then I multiply the 5 and the 8 to get 40 and the 5 and the 10 to get 50. So I changed this, instead of 5 times 10 plus 8, I changed it to 5 times 10 plus 5 times 8. That right there is what's called the distributive property. And actually what I'm going to do is I'm going to put this parenthetically, because if you just write the closure property, I'm fine with that. And similarly, this is the distributive property, technically the distributive property of multiplication over addition. But I want all that stuff parenthetical because really, you say the distributive property, I'm pretty happy. But then something weird's going on here. Let's see. I multiply the 5 and the 8 to get 40, the 5 and the 10 to get 50, and then I add the 40 and the 50 to get 90. Oh, wait a minute. I got the 50 on this side and the 40 on this side. It's saying to multiply the 5 and the 8. It's kind of saying I should multiply this, and then I should multiply this. Sounds like the problem's switching into this guy. And what I'm doing here, this is the commutative property of addition. And here I guess it's a little bit important to add addition, or at least know that you're doing the commutative property of addition, because there's addition and multiplication going on here, but it's the plus sign where I switch the order around. The 5 and the 8 are still in the same order, as are the 5 and the 10. It's just I'm adding them in a different order. So that's the commutative property. This side gives me 40. This side gives me 50. 40 and 50 is 90. That's all the properties I got. So closure, distributive, commutative down here. Whereas up here it was closure, commutative, associative. All right, next problem. What's going on here is I have a bunch of word problems, I guess, or short word problems. Looks like there's 5 of them. And I'm asked whether the set model or the measurement model would make more sense to do. So essentially the set model is like when you're taking the union of a couple of different sets, or you think about, you have some objects and you're taking them away from your set. And the measurement model, think number line. So I have 8 donuts and my wife has 4 donuts. How many total donuts do we have? This sounds like set model to me. I'm just going to write set model. I'll let you explain why. I'll talk about why so I don't have to write too much. Set model because you have objects here, right? You have 8 donuts and 4 more donuts. So when you're modeling objects like that, it makes a lot of sense to draw out 8 donuts, draw out 4 more donuts, mash them all together. You got 12. So 8 plus 4 equals 12. How many donuts do... So I guess I need to change these instructions. Then solve each subtraction problem. Using the missing add-in approach. So here, just set model, explain why you're good. I have to walk 8 miles to the donut shop, then 4 more miles to the coffee shop. How far do I have to walk before I have donuts and coffee? This to me seems like the measurement model. Again, I'll let you describe why. But to me, I just kind of picture a number line. You have to walk 8, so go out to the 8, then walk 4 more, take 4 more steps. That idea, when you're talking about distances like that, measurement model makes a lot of sense. It would be hard to do this with the set model. But would you have one draw miles somehow? Like you have 8 m's over here and 4 more m's over here. I don't think that makes a lot of sense. I think the measurement model would be better. From home, I walk 12 miles due east to get coffee, then 8 miles due west to get coffee. How far from home am I when I get my donuts? This would also be measurement model. In fact, this is very similar to B, except in B I was adding the 8 and the 4 to get 12. In C, I'm going to take 12 and I'm going to subtract 8. So really I have 12 minus 8 equals what? And since it's a subtraction problem, I want to model it, or I want to solve it using the missing add-in approach. And the missing add-in approach is when I say 12 plus what? Sorry, 8 plus what equals 12. I had 12 donuts, but gave 4 to my dog. How many donuts do I have left? This to me sounds like the set model, or the takeaway model. Because you can model 12 donuts, and then you can take 4 of those and move them out of the way, or cross them out or something. Sounds like a subtraction problem. I had 12 minus 4 equals what? If I'm going to change this to the missing add-in, I'd say 4 plus what is equal to 12. Finally, it took me 15 minutes to eat my donuts, but my wife finished 5 minutes faster than I did. How long did it take her to eat her donuts? I think this would be a measurement model also. Where this problem came along, let me write first then talk, is I was trying to think of something other than distance where I would use measurement. I think it would make more sense than sets. And I think time kind of fits that mold. Like you can sort of picture your number line as time. And it took me 15 minutes, so I'm way out at this 15. That's how long it took me. But she finished 5 minutes faster, so she's 5 minutes further over here to the left. So how long did it take her? Measurement model, I think, would make more sense. And we're trying to do 15 minus 5 is equal to what? And the way you can model that with the missing add-end is 5 plus what equals 15. All right, now basic idea here is there's 2 division problems. One's partitive, one's measurement. Which is which? I'm afraid a lot of people will switch these up because that happens all the time. The measurement model, the idea is I start out with some group and I measure subsets of a given size. And I count how many subsets I have. For the partitive model, it's a little bit different. For the partitive model, I start out with some big group, and I know how many subgroups I'm going to have. I distribute things evenly, and I figure out how many are in each group. So up here, or on one of them, I look for how many groups I have. On the other one, I look for how big is each group. So let's see which makes more sense. These donuts are too small, so a person has to eat 4 of them to be full. Okay, I have 12 donuts. How many people can I feed? So I have 12 donuts. Each person must get 4. So I'm measuring out groups of size 4. This is the measurement model up here. And the way you can write this up is you got 12, you divide by 4, you end up with 3. If you had trouble saying 12 divided by 4 is 3, you could say 4 times something. I guess I shouldn't write the answer here. I'll put the blank in. Maybe that'll be more make more sense to people. 12 divided by 4 is something. If you don't know what that something is, well, 4 times something equals 12. This is the missing factor approach, similar to what we did up here with the missing addend approach. Process of elimination, this one must be the partitive method. It is. All 4 of my friends love donuts. I'm sad that I only have 4 friends, I guess. I have 12 donuts to give away. How many can each friend have? So now I know how many groups I'm splitting these into, and I want to count the size of each group. So same problem is still 12 divided by 4 equals something, which I can still model as 4 times something equals 12, but now it's the partitive method. Talking is hard. It's the partitive method that makes more sense than the measurement method. So there you go. Hopefully your answer is a little bit more complete than this, but my goal was to talk through the explanations and just write up the answer, so I'll stop this video here.